Welcome back to this course. So today we will discuss lecture 8. So in the previous lecture we have discussed about the rounding of error and the chopping of error. So today we will go further and we will discuss the measure of errors in approximation of a number. So there basically we generally calculate three type of errors. So the first one is the absolute error. So absolute error is we write is AE. So this is equal to x, that is a number, and x star we have taken the approximation of that number. So that is called the absolute error. The second one will go for relative error. So the relative error means it gives you the error corresponding to the given number. So this can be written as x minus x star, and I am dividing it by either x if the x is there, or we can write as or x minus x star by x star. So this is the relative error corresponding to exact number, and this is the corresponding to the approximate number, because my x is the exact value, and my x star is the approximate value. So this is a approximate value. And the third one is the percentage error. So percentage error we call it PE. So this is relative error multiplied by 100. So it gives you that how much percentage the error is there in the given computation. So now we'll start further and let's do the errors in the arithmetic operations. Like we have suppose we have two numbers, like I have a number x1 and this we represent by approximate by the number x1 star, and I know that some error is there, so let E1 is the error involved in the x1. Similarly, I have another number x2, that is also we have approximated and that has some error, that is called the E2. So what will happen, so I will take the first one. Suppose we add these two numbers, so addition. Now what will happen if I add this number x1 and x2? So let's see this one. So if I add this number x1 plus x2, so this number I can write as x1 star plus E1 plus x2 star plus E2. So this is my number. Now x1 plus x2 minus, so I can take this number x1 star plus x2 star on the left hand side. On the right hand side I have only E1 plus E2 left. Now I take the modulus value. So this modulus value by the triangle law I can reduce this one to less than equal to E1, modulus of E1 plus modulus of E2. So from here I can say that the absolute error in the addition, so absolute error that is equal to x1 plus x2, the addition of the number is always less than the summation of the modulus of the corresponding absolute error in the number x1 and x2. So this gives me the not the exact value, but from here you can see that this gives me the upper bound. So that is the upper bound. Upper bound means in this case if I add two numbers and there is some errors in the numbers, already errors in the number, then the maximum errors can happen in the addition of the number is always less than equal to the modulus of the error in the corresponding numbers. So that is gives me the upper bound. So for example, I take a number x1 is equal to 0.1237 into 10 is to power 3. Another number I take x2 is equal to 0.4561 into 10 is to power 2. So I have two number, and so I write x2 as, because in this case I should have the same power of x, so I will write 0. So this one can be written as 0.04561 into 10 is to power 3. So this one is, I can write this number as, because I have added 1 0 there. Now both the numbers have the same power. Now suppose I take approximate value of this x1 star, and I suppose I round off this number at the third place, and similarly I round off the number at third place. So if I round off the number at third place, I will get 0.124 into 10 raised to power 3. So this is the number we got, and my x2 star is 0.046 into 10 raised to power 3. So that is the number we got. So in this case, suppose I want to find my x1 plus x2. So this will be, so this is the number we got if I add x1 plus x2. Now if I add x1 star plus x2 star, so x1 star plus x2 star will be 0, 4, 6, 7 and 1 into 10 raised to power 3. So this is the number we got from x1 plus x2 star. Now suppose I want to find x1 plus x2 minus x1 star plus x2 star. So this is the number I want to find. So this will be equal to minus so this is equal to, so it will be, so this is the bigger number. So from here I can calculate this value. So this will be so 931. So 170 is 931. So this one can be written as 0.00069 into 10 raised to power 3. So that is the value we got the errors when we add these two numbers. Now I want to see that what will happen if I calculate the error in x1 minus x1 star. So x1 minus x star, so this is the number 12370 minus 12400 into 10 raised to power 3. So it has a 400, so 370, so it is 0.0003 into 10 raised to power 3. So that is the error we got in the, so this is my E1, and x2 minus x2 star, so this is my x2, so 0.04561 minus 0.04600 into 10 raised to power 3. So in this case it is 600 and 561, so it is I can call it 0.00039, because these 600 minus 561 is 39, and before that is 20. So, this is the into 10 raised to power 3. So, that is my E2. So, from here I can say what is my E1 plus E2. So, E1 is plus 0.00039 into 10 raised to power 3. So, it is 0.00030. So, it is 69 into 10 raised to power 3. So, that is the maximum error it can happen when we do the addition. So, that is the answer we have. So, that is the error happened in the term of x1 and plus x2. So, I think this calculation is okay and we can move further. So, this is the addition we have done and we got this error in the addition. Now, next one we go for the subtraction. So, suppose we have two numbers, the same number, and I want to subtract x1 minus x2. So, this one can be written as x1 star plus E1 minus x2 star plus E2. So, from here I can write x1 star minus x2 star plus E1 minus E2. So, from here I can write that x1 minus x2 minus x1 star minus x2 star. So, in this case I am taking the subtraction of two numbers. So, this will be equal to E1 minus E2. So, by the triangle law it can be written as E1 plus E2. So, it has the upper bound for the subtraction. Similarly, in the case of addition we have seen. So, that is the absolute error in this case. The third one is what will happen if we do the multiplication. Because if you see in the previous also, the maximum error E1 and E2 was 0.0069, and if I taken the error in this case, so that was also coming 0.0069. So, it is by chance that these two numbers are coming, but definitely this error cannot be bigger than this one, because this is the upper bound we can have. So, that is the upper bound we can have in this case. So, in the multiplication what we will do, suppose I want to calculate what is the x1 into x2. So, this one we want to calculate, and we want to see that how the error will propagate if we multiply the two numbers. So, this is x1 can be written as x1 star plus E1 x2 star plus E2. So, this is the number we have. If I multiply this one, so it can be written as x1 star into x2 star plus x1 star E2 plus E1 x2 star plus E1 plus E2. So, now in this case we know that the error is always very small. So, E1 is very small, E2 is also very small. Then from here I can say that E1 and E2 is very much small as compared to E1 and E2. So, this two value is very small and we can ignore this value. So, we can ignore this one. So, from here I can write that x1 into x2 minus, so this factor I will take on the left hand side. On the right hand side I will get x1 star E2 plus E1 x2 star. So, this will got. Now, suppose I take the modulus of this, then it is not going to give any information, because the right hand side vector is also dependent on so I can write like this one, but in the right hand side vector it is also dependent on x1 star and x2 star. So, we cannot make any conclusion in the terms of the absolute error. So, in this case what you do, I will try to find the relative error. So, what I do is I will divide it by the number x2 x1 star into x2 star, and then I take the modulus. So, this one I can write as x1 star E2 divided by x1 star x2 star plus E1 x2 star x1 star plus x2 star, not plus, it is multiplication. So, that is equal to x1 star x2 star. So, this will cancel out. So, from here I can write that this should be equal to E1 by x1 star plus E2 by x2 star, and that is, what is this? It is the relative error in x1 and this is the relative error in x2. So, from here I can say that the relative error in x1 x2 is less than equal to relative error in x1 plus relative error in x2. So, that is the, we can have the upper bound in the relative error when we multiply the two numbers. So, this is we have done for the multiplication, and the last one we can do the division. So, what will happen in the division? Now, let I divide the number x1 by x2. So, in this case what we will do? This can be written as x1 star plus E1 divided by x2 star plus E2. Now, I can take the number x1 common from the numerator and x2 star from the denominator. So, this will become 1 plus E1 by x1 star, and this can be written as 1 plus E2 by x2 star. So, this can be written as, now I can write as a x1 star x2 star, and this one I can write as x1 star 1 plus E2 x2 star inverse. So, this number I can take, and now this number is, this is a binomial. So, I can expand this one using binomial expansion. But I will ignore the higher power of, so ignoring the higher power of E1 or E2 or E1 into E2. So, like this one I can ignore. So, from here I can write x1 star x2 star. So, 1 plus E1 by x1 star 1 minus E2 by x2 star, and all other term will carry the higher power. So, that we can ignore, and then we can do the further calculation. So, this will, it will be 1 plus E1 by x1 star minus E2 by x2 star, and then minus of E1 E2 x1 star x2 star. So, this one I can ignore because it is, gives the value of E1 and 2, which become a very small quantity. So, from here I can write my x1 over x2. So, I will take this quantity on the left hand side. So, this will become x1 star over x2 star. On the right hand side I will get this x1 star will cancel out. So, I will get E1 over x2 star minus, and here I will get x1 star E2 divided by x2 star whole square. So, in this case also, the, if I want to find the absolute error, it is not going to give any upper bound because it is dependent on this one. So, in this case what I will do, I want to find the relative error. So, I will divide this by x1 star over x2 star. So, I will divide this number by this x1 star over x2 star. So, this number will give you, so that is, and then I will take the absolute value. So, this on the left hand side gives the relative error in x1 by x2. On the right hand side, if you see, this will divide by this. So, x2 will cancel out, it will give you E1 over x1 star from here minus. So, this one x1 will cancel out, so it will give you only E2 by x2 star. So, that is the number we got in this case. So, this is 1 plus, so this is the one I have taken the left side and this. So, that can be written as E1 over x1 star plus E2 over x2 star. So, this can be written as relative error in x1 plus relative error in x2. So, by using this one, we can define that the relative error in x1 divided by x2 is always less than equal to the relative error in x1 plus relative error in x2. So, in this way we can find the upper bounds on the relative error in when we divide the number x1 by x2. So, these numbers we are always gives the upper bound. The next thing we can give a that how the calculation is, when we do the calculation, how the number of significant digits can be lost. So, this is I give you the one example, that loss of significant digit. So, that is also comes as a numerical instability. So, what is the numerical instability? Because sometimes we do the calculation, we know that at each times we start doing the computation, we are multiplying the two numbers, subtracting the two numbers, dividing the two numbers. So, in this case, the whatever the at the starting we introduce some rounding of error or the chopping of error. So, that errors will grow as we do the computation. So, it depends that sometime it will happen that then my results will becomes unbounded, or it tends to diverge. So, in that case we say that our computation is numerically unstable. Otherwise, if it is giving the correct answer, then we call it the numerical stable. So, how will happen? So, this is the one form I can say. That first one is we call it bad subtraction. So, what is the bad subtraction? Suppose I have a number, one number is x1, approximate number, and another number is x2. Only thing is that x1 and x2 is of the same magnitude. Then sometime it will happen if I subtract one number from another number and both the number are of the same magnitude, then what will happen? We lose some significant digit. So, in this case it is called the bad subtraction. For example, suppose I take a number x1 star is some number I am taking, it is 178,693 into 10 raised to power maybe 2, suppose I write, and another is y2 star or x2 star, that is another number, and that is 0 equal to 178,439 into 10 raised to power 2. So, suppose this is the two number, and if you see that this number have the same magnitude, it is 1.1786, it is 0.1784 and the same power of 10 raised to power this. So, these two numbers are the same magnitude, and suppose I want to do subtraction. So, if I do the subtraction in this case, what I will get? I will subtract from here. So, it will be 4, 5, 2 and then 0, 0, 0, 0 into 10 raised to power 2. So, in this case, if you see from here that my number in these numbers I have a 6 significant digits. In this also we have a 6 significant digits, but in this case I can write this number as 0.25 4 into 10 raised to power 2 was already there, and I will write it is 10 raised to power minus 3. Okay. So, in this case what will happen? I will lose my significant digit. So, now this number has 3 digits. So, earlier I started with the 6 significant digits, and now I deal with the number that has the 3 significant digits. So, this number is 0.254 into 10 raised to power minus 1. So, from here I can say that this is a loss of 3 significant digits. So, this is all about that how the error grows, or how we can find out the upper bounds of the error when we do the subtraction, addition, multiplication and division of the two numbers. So, in this we have discussed about that how we can also lose in the computation how a significant digit can be lost. So, this is all about in this lecture. Thanks very much. In the next lecture we will go for further. Thanks very much.